Assalamualaikum and good morning. My name is Amiera Fazlin binti Kamarudin and my partner Yong will presentation about wheel hub and knuckle for assignment to automotive component manufacturing. Introduction of wheel hub. First, a case of manufactured metal part located between the suspension of the vehicle and the wheel. Second, the hub has a wheel flange on one end to fit the brake rotor or brake drum and the wheel. And from the other end, the hub has a wheel inside or above it. Third, wheel hub assembly between the drive axle and the brake drum or disc on each wheel. And lastly, on the disc side of the brake, the wheel is attached to the wheel hub bolts. Steel and aluminum is a material for processing of wheel hub. They have 15 steps for manufacturing a wheel hub. First, making a hollow cylindrical iron tube to form a plurality of partially finished axle tube. After that, shape to have a plurality of small wave portion and large wave portion. Third, predetermine distance on the upper and lower portion of iron tube by swagging. Fourth, cutting iron tube as a plurality of single piece. 5. Having a small wave portion around its mingle and two large wave portion flaring at its end be in a trapeze shape. Continue with the sixth step. Stamping both large wave portion to form two hub flange. 7. Pressing two bearing ball step to form. 8. Shape and to provide a axle hole in a bottom center to insert into ball. 9. Define as the rear portion of bearing. For 10th step, the diameter of the inner front portion of each ball recess being slightly smaller than the diameter of the outer rear portion. We continue with introduction of steering knuckle. Steering knuckle is the component that attach the brake pedal to the steering wheel. Second, it's usually a forged or cast assembly that contains either a hub or a spindle. Third, the knuckle is attached to the wheel assembly and to the steering component on the others, and it comes in various sizes and design, often to match the vehicle's drivetrain, brake type, and suspension type or geometry. Material to produce of knuckle. First, nuclear cast iron. Second, forged steel. Third, forged aluminum. And grey or white cast iron used for race car. To produce the knuckles, first step start with casting using casting mold method, and second, forging the knuckle. Third is trimming the knuckle to shape and heat treating the trimmed knuckle. 5. To process the heat treated knuckle union and then assembly 3 or more brushes in the knuckle. Then assembly at least 2 sockets into which a ball joint is fitted to be connected to the arm of the suspension device in the knuckle. And lastly, the knuckle of the present if attached are complete and be manufactured.
Good day everyone, my name is Lo and I'm going to show you the drawing, assembly animation and the stimulation test of the wheel hubs and knuckle. So this is the drawing of the wheel hubs. Then the designer dimension of the wheel hubs is about 20 cm in outer dimension. Moving on to the knuckles, the designer length is about 30 cm in length. So this is the exploded view of a simple car view system. So I'm not going to use all the components that involved in this exploded view, but I'm just choose the knuckles and the wheel hubs to run the stimulation test for my assignment. So this is an assembly animation that I have done by using SolidWorks, and from in this assembly animation we are going to see how the disc brake, the wheel hubs and the knuckles are joined together to form a simple car wheel system. So moving on to the simulation test, I have done the static test for both of these parts, and this test is based on a situation of an emergency brake, and from this testing I'm trying to find out the torque force that can be withstand by the wheel hubs and the knuckles. So based on an emergency brake situation, the fixed geometry of a wheel hubs will be on the screw which is attached to the disc. The force direction of the wheel hubs will oppose the force direction of the disc brake. So from the diagram you can see that the force is anti-clockwise, and also the torque force is set on 1500 Newton per meter square. In this assignment, I have chosen alloy steel as the material of the wheel hubs, and this is the animation test of stress when the force is applied. The first result is from simulation on stress. The maximum stress is about 1.86 power of 8 Newton per meter square, and the minimum stress is about 0.15 Newton per meter square. The next result is from simulation on strain. The maximum value is about 6.6 power of negative 4, and the minimum value is about 1.3 power of negative 12. The next test is simulation on displacement. The maximum value is about 3.8 power of negative 2 millimeter, and the minimum actually can be ignored because the value is very small. From this slide we can see that the auto-generate factor of safety for the wheel hubs is 3.3. It is considered as a safe product due to the fact FOC is bigger than 1. Moving on to the next part, knuckles. So the fixed geometry of the knuckles is on the screw, the hole of the screw that which is fixed to the hubs. The force directions of the knuckles is same as the wheel hubs, which is opposed to the force direction of the disc brakes. So because of the wheel hubs has already offset sun of the force. So the force that transfer to the knuckles will be reduced to about 1000 Newton per meter square in torque force. I have chosen the gray cast iron as the material of the knuckles. So this is the animation test of stress when the force is applied. So moving on to the result of simulation test. The first result is from simulation on stress. The maximum stress is about 82 power of 6 Newton per meter square, and the minimum value is about 2400 Newton per meter square. So the result is considered as good result because the maximum stress does not exceed the yield strength of the material. The next result is from simulation on strength. The maximum strength is about 1.01 power of negative 3, and the minimum value is about 5.9 power of negative 11. The last result is from simulation on displacement. The maximum value is about 3.7 power of negative 1 millimeter, and the minimum value is considered as and can be ignored because the value is very small. The auto generate factor of safety for knuckles is 1.9. It is also considered a good material for construct the knuckles because the FOS is bigger than 1. In conclusion, alloy steel is considered as a suitable material for wheel hubs. By referring to the simulation result, the component can successfully withstand 1500 Newton per meter square torque force without failure. So the same results for the knuckles. The gray cast iron shows the good characteristic in withstanding force and pressure, and also for the safety factor bigger than 1 for both parts, shows the good properties in both of these components. So which means the component is safe to use and it can be bent easily or changed in shape when the force is applied. So that's all the presentation from me and my teammate Amiera, and thank you for your time to watch and listen this video.